So let's look at how we're going to use the second introduction. So we're going to start with the examples. So we can see x equals minus b over 2a plus minus the square root of b squared minus 4ac. It's kind of complicated over 2a. Whether you make them one fraction or two, it's still kind of an involved process. And you want, if you know you can factor a quadratic, instead of using the quadratic formula, then it's certainly to your advantage to do so. So if we look at GP1, the first thing you want to ask is, can I factor it? So we look at 2x squared plus 9x equals 18. We put it in standard form. 2x squared plus 9x minus 18 equals 0. And so we want to look at, can we factor it? So we're going to take 2 times negative 18, a times c, which is negative 36. And so we're going to look for factor pairs of negative 36 that combine to equal 9. So if you go through the steps, however you want to do it, we're going to do, since we know that the factors are going to be positive and negative because 36 is negative, because the product of the two numbers is negative. And the middle b is positive, so we know the bigger factor has to be positive. So we can be systematic. If you want, 36 times negative 1 is 35. 18 times negative 2 is 16. And 12 times negative 3 is 36, and that's 9. So we can see that it factors. So you can go ahead and finish the factoring. You can write out 2x squared plus 12x minus 3x minus 18 equals 0. Factor it in pairs. You can see 2 and 12 make a 1-to-6 ratio. Negative 3 and negative 18 make a 1-to-6 ratio. So we take 2x out of the first two terms, and that leaves x plus 6. And we take negative 3 out of these two terms, and we get negative 3 times x plus 6 equals 0. And now we have 2x minus 3 times x plus 6 equals 0. Now, we can also factor this with using the technique done by other teachers. The cross method, negative 36 goes here, 9 goes here. You figure out your two key numbers, 12 and negative 3, make negative 36 combine to equal 9. And then you write the two parentheses with x plus 12 and x minus 3 in the parentheses, and then divide both of the second numbers by 2. And that's going to give you x plus 6 because it goes evenly, and then it doesn't go evenly into the 3, so multiply the x by the 2 and you get 2x minus 3 here, and you get the exact same factors with the other method. So either way, we get our factors. Now, anyway, so the first thing you're going to do when you're working on something is you're going to see if it factors. Now, if we look at, let's go to the second guided practice, and let's check that out. So GP2A, and with GP2A, here, let me move this thing down to it. Let's see. Okay, we got 4x squared minus 24x plus 35 equals 0. Now, a equals 4, b equals negative 24, and c equals 35. Okay, so 4 times 35 is 140. And you can see that the product of, this is positive, so both factors are going to have to either be positive or negative. In other words, you have to have the same sign. And the middle b, the middle coefficient, is negative 24, so they both have to be negative. And so right away you can see it's going to be negative 14 and negative 10. And so you can proceed to factor it, and but you don't need to use a quadratic formula. That's the point. Okay? So that's your first course of action. So don't use the quadratic formula, you don't need it. So let's look at GP2B. And let's see what's happening here. So we got 3x squared minus 2x minus 9 equals 0. Okay, so we got negative 27. A times C is negative 27, and we're looking for factor pairs of negative 27 that combine equal negative 2. One positive, one negative. Okay, so there's a it's not impossible because we're doing we're doing a difference. So we got the middle coefficient is negative 2, so the bigger factor should be negative. So we can just do negative 27 and 1, and that's not it. And we got 3 and negative 9, and that doesn't do it. And that is it. 27 is 3 times 3 times 3. There is nothing else we can try. So we're kind of out of business here. So does not factor. Okay, doesn't factor, then we use a quadratic formula. Now let's write out the numbers. A equals 3, B equals negative 2, and C equals 9. When you're first using this thing, or you haven't used it for a year or something, it's good to be somewhat methodical about it. So write the formula out. X equals minus B plus minus the square root of B squared minus 4AC all over 2A. And now plug the numbers in and go. So X equals, oops, I don't want that. Okay, so nice. So, right, put the negative sign, open parenthesis, negative 2 in parenthesis, plus minus the square root of, open parenthesis, negative 2 squared, minus 4 times A, which is 3, and C, which is negative 9, extend that 9 a little, all over 2 times 3. Okay, now, let's double check everything. A is 3, B is negative 2, C is 9. If you get any of this wrong, you're just wasting your time. Okay, minus B plus minus the square root of B squared minus 4AC all over 2A. Fine. Okay, minus negative 2 plus minus negative 2 squared minus 4 times 3 times negative 9 all over 2 times 3. Okay, so now we start simplifying. X equals 2 plus minus the square root of 4 plus, okay, we got 36 times 3, which is what, 108, or 9 times 12, yeah, 108, all over 6. All right, and X equals 2 plus minus the square root of 112 all over 6. Now, at this point, 112 can be simplified, although we haven't done a lot of work on how we simplify radicals. Well, actually, I think we have. Namely, you look for perfect square factors that are inside the radical, that are factors of 112. It looks like 4 is going to go. And it looks like, here, let's see, 112 divisible by 4, 2, and then 4 goes 4 times 8, and then we got 28. And 28 doesn't have anything. So we could have X equals 2 plus or minus 2 times square root of 28 over 6, which is going to simplify to x equals 1 plus or minus the square root of 28 over 3. Now, let's see what the answers to this. Let's check this on the calculator. Let's see what we got. Normally, I would like the answer left in this form, rational radical form. In the book, the answers are in decimal form. So let's see what we got. So we're going to have, I'm going to do an open parenthesis, 1 plus the square root of 28, close parenthesis, divided by 3. And let's see what I got. And that is one of the answers. It's rounded to 2.1. So we get the second answer, second, and then enter, puts the same formula back up that we just put in, and I'm going to arrow over to the plus and make it a minus. And I hit enter, and I get negative 1.4. And so those are the two answers. So x, it's approximately equal to 2.1, comma, negative 1.4. That's what they have in the book. All right. This is a legitimate instance in which you would use the quadratic formula. And you can see, it's not the easiest thing in the world to use. All right. So let's go on. That's GP2A, 2B. Now, if we look at GP3A, let's go to GP3A. Okay. And let's see if it factors. And we got 2x squared minus 17x plus 8 equals 0. 2 times 8 is 16. It's positive, so we're going to have either two positive or two negative factors. And you can see right away, negative 16 times negative 1 equals 16, and it sums to negative 17. So it factors. So go ahead and factor it if you want and get your answers, but we're not going to use the quadratic formula. So let's look at GP3B. 4x squared minus 4x minus 11 equals 0. Okay, now we got 4 times negative 11. We got negative 44. Now we're looking for factor pairs of negative 44 that combine to equal negative 4. Okay, so we got negative 44 and 1, which is negative 43. That's not what we want. We got negative 22 and 2, which is negative 20. And we got 4 and negative 11. And that's really all we got, because we only have 2 and 2 over here and 11 and 1 over here. So there are very few combinations that we can work with here. And we've got them all, and none of them combine to equal negative 4. So we are going to use the quadratic formula. Does not factor, or we would say it's prime. Okay? So I'm going to do the A equals 4, B equals negative 4, C equals negative 11. I'm going to write out the formula. X equals minus B plus minus square root of B squared minus 4AC all over 2A. This is a formula you have to remember. It will not be given to you. Okay, so let's plug in the numbers and go. X equals minus negative 4 plus minus the square root of negative 4 squared minus 4 times 4 times negative 11 all over 2 times 4. Okay, now let's double check. Minus b plus minus b squared minus 4ac all over 2a. Let's check our coefficients again. 4, negative 11, A, B, and C. And now let's see if we put them in right. Minus negative 4 plus minus the square root of negative 4 squared minus AC, minus 4 times AC, minus 4 times 4 times negative 11. Okay. So far, so good. X equals 4 plus minus the square root of 16 plus 44 times 4, okay, which is 88. 88 times 2, which is what, 176. I'm going to work that out and double check that. Plus 176. So 16, let's do 16 times 11. We got 16 and we got 16, 176. That's right. Over 8. Okay. So X equals 4 plus or minus the square root of 186, 192 over 8. Okay, now 192 is divisible by 3. It's not divisible by 9. Is it divisible by 4? It is. Okay, so let's see if we can break down 192. So 192, I'm going to divide it by 4, and it goes 4 times is 16, 32, 48. Okay, now 48 has 16 in it, right? So we've got 192 here. Let's do a little. Is 4 times 48, and 48 is 16 times 3. So 192 is divisible by 4. 16, 3, 32, 8. Alright, so let me stop this for a second so I don't bore you while I'm working this out myself. So 192 is 64 times 3. So we're going to end up with X equals 4 plus or minus the square root of 64 times 3 over 8. So X equals 4 plus or minus the square root of 64 times the square root of 3 over 8. X equals 4 plus or minus 8 root 3 over 8. And we have two terms. 4 is a common factor for both, for the denominator. So X equals 4 is going to cancel once, twice, and twice. So we got 1 plus or minus 2 root 3 over 2. The 2 cannot cancel into this term unless it cancels into this term. Okay? Notice the axis of symmetry is going to be 1 over 2, 1/2. Just like in the previous problem, the axis of symmetry was 1/3. Okay, so the axis of symmetry here is 1/2. And, all right, so let's check our answers. So, get the calculator. Now, like I said, increasingly in the future, you'll just leave it in rational and what's called rational and radical form. In other words, we got a ration, right? And we got a radical, so it's called rational and radical form. All right, so let's work this out here. So we got open parenthesis, 1 plus 2 times the square root of 3, close parenthesis, the second parenthesis closes the numerator, divided by 2, and I hit enter, and let's see if that's one of our answers. Let's see. Yeah, 2.2 is one of them. Okay, so that's correct. And then let's go do the other one. So second enter. Now I would be quite happy giving you these problems as no calculator problems, and you just leave your answers in simplified rational radical form. Okay, and this one's also correct. So this is approximately equal to, according to the book, 2.2 comma negative 1.2. All right, so we're getting near the end of this whole thing now. So let's get to this. So here's a little chart that's very very useful. Gives you all the methods. Okay, now so you can do factoring, graphing. Graphing, you know, when you want to find the exact roots, graphing isn't going to be all that useful to you. You use square roots when there's no middle term. Okay, so then when there's no x to the first term, or as they say here, equation has no x term, completing the square. Very handy, but it can be a little clumsy if a is not equal to 1 and b is not an even number. But still, strongly recommended. In a lot of ways, it's much simpler than using the quadratic formula. Quadratic formula always works. Okay, now, we did not get to this on Friday, but it is a really useful thing called the discriminant. Discriminant is simply b squared minus 4ac. Now, here's the deal with the discriminant. This is like your first step into the world of analysis. Namely, you're not specifically doing algebra to figure something out, but rather you're analyzing the equation to get some truths from it by thinking. All right, so let's look at the quadratic formula. X equals minus b plus minus the square root of b squared minus 4ac. Now let's split this up into two fractions just for a second here, the way I kind of like to do it. Okay, now minus b over 2a, axis of symmetry, x-coordinate of the vertex, right? Okay, so that's always going to be graphable, okay? That's always going to be the x-coordinate of a point, and if you on the graph. And if you take minus b over 2a and plug it into the equation, then you are going to have the y-coordinate of the vertex, and you'll have a point on the graph. Now, you have plus minus the square root of b squared minus 4ac over 2a. Now, let's talk about this for a minute. If b squared minus 4ac, it's a square root, is less than 0, then the graph does not cross the x-axis. It has no real roots. No, now it has roots, but they're not real. They're complex. No real roots. Okay, so the graph is going to look like this. It's either going to go like this, or it's going to go like that, somewhere on the, but it will never cross the x-axis. That's if b squared minus 4ac is less than 0, because the radicand, b squared minus 4ac, is the radicand, and if the radicand is less than 0, it's not. The numbers are not real. They're complex, which is fine. They're very important. We get a lot of use out of them. That's why we don't like calling them imaginary anymore. But they don't cross the x-axis. The graph doesn't cross the x-axis. Okay, now, if b squared minus 4ac is greater than 0, it's clear that there will be two real roots. So if b squared minus 4ac is greater than 0, the graph is going to either do this or it's going to do that, something along those lines. Okay, it'll hit the graph going down and then back up, or it'll hit the graph going up and then back down. Hit the x-axis. Okay, that's if b squared minus 4ac is greater than 0. Now, if b squared minus 4ac equals 0, now let's look at the equation again here. So if b squared minus 4ac equals 0, you're taking the square root of 0, which means you're going to have 0 over 2a, so there's no plus or minus anything. Now, it doesn't mean there's no real roots. It just means there's 1 minus b over 2a. Because if b squared minus 4ac equals 0, you have a perfect square. And it touches the x-axis in 1 point. Something like that, or like that. 1 real root. So that the axis of symmetry is also the single root. The single real root. Although we call it, because it's a perfect square, so you would have a minus b squared. B is a double root. We consider, they still say there's two solutions. They're just both the same thing. All right. And so how do you use this here discriminant? Well, it's just really easy. You're just using it to figure out how many solutions you have. So let's do these guided practices here real quick. And we're done. Okay, so GP for a 2x squared plus 11x plus 15 equals 0. Now let's first of all make sure that this thing doesn't factor before we start. Well, actually, no, let's just do the discriminant. So b squared minus 4ac. So a equals 2, b equals 11, and c equals 15. So b squared minus 4ac equals 11 squared minus 4 times 2 times 15. Now, let's see what we got here. We got 121 minus 4 times 15 is 60 times 2 is 120, which equals 1. Okay? So, how many real solutions do you have? You're going to have 2 real solutions, because it'll be minus b over 2a plus 1 and minus b over 2a minus 1. And that's going to be your roots. Okay? So it's greater than 0, so there's 2 real roots. Now let's do the second one. 9x squared minus 30x plus 25. Now I'm not even going to bother to find out if it factors. This is an exercise for b squared minus 4ac. A equals 9, b equals negative 30, and c equals 25. So we're going to analyze the radicand. B squared minus 4ac. Negative 30 squared minus 4 times 9 times 25. Okay, so this is 900 minus, well, 4 times 25 is 100, minus 900. So it equals 0. Okay, so there is 1 real solution. All right. Now, if this were 9x squared minus 30x plus 100, then we would have minus 30 squared minus 4 times 9 times 100, which would be 900 minus 3600. No real roots. Okay, complex roots, yeah, great. We love these complex roots, but none of them that are real. The graph does not cross the x-axis. Okay, that's it. Head for the homework. I'll send out something for the homework